All right, welcome guys to day one, mathematical definition of the derivative. Let's hope that this doesn't crash. This is my second take because the first take, the recording crashed. So thankfully it was only a couple minutes in, so I didn't lose that much time here. Just note that we are in Unit 9. Just make sure you're not mixing this up with like Unit 8 stuff if you're still working on that. Make sure you catch up. This is the set of notes where we're going to go through a lot of the like minutia and like the what's it called, basics using limits to find a derivative. And it's gonna get real tedious real fast. You guys thought that like proofs for trig were like a pain in the butt. This may take the cake depending on how you look at it. And once we get to day 2, you're gonna be like, wait, Mr. Park, why did you just tell this the shortcut in the first place? And I remember I said last time or in the last video, concepts. Get the concepts down, then we can do the shortcuts afterwards. Okay, so let's get the concepts down here. This is just a refresh of the definition of derivative. How many times have I told you the definition of derivative? There's a reason why it's really important. Once you get to the AP style questions at the end of next year, you're going to be glad that we are honing in like the definition of derivative, because if you don't get this, there's no way that you're going to understand what the AP questions are asking you for. You thought the assessments or the check-ins this year were hard. Wait till you get to the exam, because it's going to be like, you studied for this on the test. And then you go to the test, and it's like nothing exactly like you studied. It's like because it's an application of what you've done. It combines all the concepts together. Okay, so let's go through this. We're going to talk about this particular formula here. Just make sure my face isn't blocking that. Perfect. Now, you can either use this one or this one. Most of you will probably prefer the right one simply because it's h instead of delta x. And delta x is kind of confusing because it looks like x, but it's not the same, but it is the same, but it's not. So just for simplicity's sake, we'll just go with the h1 on the right side. And so what we're going to do is we're going to finally construct or find the derivative analytically. Instead of graphically, we're going to do it analytically. Hopefully we know what limits are by this point. If not, go back to Unit 8, refresh yourself on limits there. So I'm going to skip number 1. Number 1 is really easy. Once you get to the answer there, I'll have the key up so that you can check your answers just to double check there. What we're going to do is we're going to start with this guy right here. And the reason why I like this one is because this is a good problem where it's an application of not the things you just learned in Unit 8, but there is an application with what we did on the Unit 7 stuff, which I just realized. If you're in BC Prep, you guys never learned about binomial theorem. So this right here, we can use the binomial theorem, but I just realized AV Prep students learned about binomial theorem. BC Prep students did not. Not a huge worry. I mean, we can do it, you know, the old school way, but if only we had the binomial theorem. Drats. Okay, well, my key is going to be a little bit off here, but we can do it the long route that we're going to do right now. So here's what we're going to do. We have the function given to us, f of x. What we want to find is f prime of x. Okay, so scroll back up. How do we find the derivative, or f prime of x? What's that formula that we had? We were told that it's basically the limit as h approaches 0 of, and I'm just going to rewrite the whole thing down just so you have it. The y value, not plus, sorry, it should be minus the y value, all divided by the h itself. If you are still like, what the freak are these random things written together here, go back to the last day's notes. You should be able to find it in the hyperdoc. Basically, I kind of talk about why we have this like weird plus h thing and then divided by h. This effectively is the slope formula. In like a big picture, like here's TLDR, you know, like SparkNotes version. This is the slope formula. It looks weird, but it's basically the slope formula. The plus h is super important as well. I think I talked about it on day 0, which was yesterday or the last day. But I also talk about it in either one of the first 2 videos I created for Unit 8. So if you need to go back, please go back and see why is it that we have this formula and existing in the first place. If once you get that, once you see this, this will make sense. And then later in the second half of this video, you'll see, oh, okay, connections, light bulbs going off. That's the point. So what we're going to do is we first need to find out, probably the hardest part is this right here, f of x plus h. What that really just means, going back to algebra 1, is you take the function, so here's f of x, right? F of x is equal to x cubed. I'll erase this in a second. You're just plugging in x plus h. So on the right-hand side, everywhere you see x, you plug in x plus h. That's it. So once we get to this part here, let's go ahead and write the rest of it down. We're going to say the derivative is equal to this. Notice how I'm writing the limit, again, as annoying as that's going to be. That is necessary because we haven't actually found the limit yet. We'll get there eventually. We haven't gotten there yet. So it's going to be, what is it? quantity x plus h squared minus f of x. Well, f of x we know was provided right here, so we just copy and paste. And h is simply just h. Okay. Now at this point, this is when we first checked, as we did with limits, can I simply substitute h equals 0 into our expression here? And hopefully you quickly realize that it won't work, because what happens to the top and what happens to the bottom? You get 0 over 0, indeterminate form. Can't do that. So what you effectively want to do at this point, and we've kind of done this before with limits, is you want to somehow get that divided by h factored out or canceled out. So let's go ahead and go with this. And I just realized that I put the wrong thing there. I almost went about this problem without understanding what I just did wrong there. So this should be cubed, not squared. Sorry for those guys who are like festering, like, Mr. Bird, you can't write 3's correctly. I'm like, I get it. I make mistakes. It's cool. Chill. So what we're going to do now is we're going to expand that out. Okay. And just to save a little space, I'm going to do it on the top here. So remember, x plus h squared, right? You can just simply think of it as x plus h times x plus h times x plus h. Okay. So we can just do the first two. That's easy. That's just, as you would call it, foiling, or for those guys who have Mr. Geisy next year, he's going to harp on you saying that this is not foiling. Foiling is like the worst effort you can use. It's double distribution. You're taking the first one, multiplying by the 2, and then take the second one, multiplying by the 2. So double distribution. Just keep that in mind. We get x squared plus 2xh plus h squared. Yep. Quantity x plus h. And so now we have to do distribution of the 3 terms on the left side to the 2 terms on the right side. So, as annoying as it's going to be, we get x cubed plus 2x squared h plus xh squared plus, since we have the plus sign there, plus, multiply everything by h, x squared h plus 2xh squared plus h cubed. Okay, I'm not going to proceed from here in terms of simplifying this out, because you can just look at which terms combine together. Here is what you end up getting. You get x cubed plus 3x squared h plus 3x squared, or 3xh squared plus h cubed, and then bring the rest of the original back from the limit, and we're left with this. Okay. Now some of you might think that's really tedious. Why do we expand that? That just made the problem worse. I'm like, we're making the problem look worse so that certain things cancel out, and then eventually it'll look better. Now for those guys who are like, Mr. Park, you talked about this binomial thing, right? It's called the binomial theorem. You can ask your AB prep counterparts here, or your fellow classmates about this. I also have posted this on OneNote, so you can actually look it up really quickly, and I have the entire notes set up there. But if you take a quick look at it, it's just an easier way to deal with binomials, like x plus 2, whole thing to the 7th power. How do you do that without doing it manually, like just doing it right here? Now, thankfully, this is only to the 3rd power, so it's fairly easy to do it by hand. But if this was to the 7th power, right, that's gonna take a while. And so there's something called the binomial theorem, in which you use Pascal's triangle. Maybe you've heard it before, maybe not. Google it real quick. Use Pascal's triangle and use the idea of distributing terms, and you end up getting the answer really quickly. So using binomial theorem, I would have reached this answer much quicker than if you guys were doing it by hand. But it takes a little bit of practice. It's a unique sort of thing. It's a niche kind of concept. So if you have the time, go and try that. You will probably need it when you get to the C portion of BC Calc, like the latter half of the year. But for now, we'll get through it without it. Okay, so then we start looking at what we can cancel out. We notice that the x cubes will cancel out. And then another thing we can notice is, we'll do 2 steps in one here. If you take a look at the remaining terms here, notice what do they all have in common? Oh, they have all h's. So you can factor out an h, and hopefully this is where the light bulb kicks in for you. That's why we're doing this in the first place. We're left with this. And hopefully you see something in the numerator and the denominator potentially canceling out. And so finally, we are left with this. There's no fraction anymore. I can now substitute h equals 0 and have no repercussions of indeterminate form. And so we're going to say that the derivative is equal to, plug in h equals 0 to h, we are left with this. That's it. You found the derivative. So derivative of x cubed is going to be 3x squared. Again, as a foreshadowing, tomorrow when you learn some other special rules, you're going to be like, Mr. Park, that's so many steps. That's like 8 steps there. And you're going to exaggerate, right? But let's just exaggerate for fun here. That's 8 steps there. when if you just show this a shortcut, that would have just been 3. Or not even 3, that actually be like 1. And again, start with what does a derivative really mean. We're using kind of like a slope formula here. And effectively, this is slope formula. You might not see it, but that's really what it ends up being. When you go back to like the videos I talked about what this really looks like graphically, you're really just taking the slope of the secant line, and as the 2 points get closer and closer together, you will effectively get the tangent line, and that is what you're finding here, the slope of that tangent line. Okay. Moving on from there, this one should not be too bad. I think I want to try number 4. This one would be the one I want to go with. So same process, f prime of x is equal to, same idea. It's going to be the function itself, but replace x with x plus h. This was not too bad. And then you're going to subtract f of x, which is just whatever that is right there, minus h, or divided by h, sorry. And of course, Mr. Park missed on some important things here. As I harp on you guys about not putting the limit, I should also put the limit as well. Okay, plugging h in obviously won't work, it's divided by h. So now what do? Can we combine the tops together? Well, they're not the same basis, so no. And so this is where our infamous R word comes into play. Remember the idea of rationalizing? So let's try that. Let's do it in green. If you rationalize the top, you take the conjugate, which is the exact same term as the top. The only difference is now you're adding, or you're doing the opposite of whatever was given originally. Same concept below. Okay, I'm still questioning if I should keep going because I'd rather do the problems below, but I don't have the timer of how long I've been talking. So if you want to skip, go ahead and skip. If you want to stay for the ride, go for it. Again, making sure we write the limit again. And let's go ahead and do that. The top is going to basically factor out or simplify to x plus h. It's going to be a minus sign. Square root of x times square root of x is just x. And then the bottom, don't distribute. Do not distribute. I'm telling you right now, do not distribute. Remember, what's your goal for the denominator? You want that h to basically cancel out. So keep it alone by itself. You'll see maybe in a second why. We'll see certain things cancel out here. Same thing, write the limit again. Notice that I don't complain. Okay. Hopefully now you now see why we didn't cancel the h in the first place, because now it cancels out. Or sorry, why we didn't distribute the h in the first place, because now we can cancel it out. So we're left with this. And now you try the plug and chug and see what happens from there. Okay. Now, go ahead and pause if you need to, rewind if you need to as well. Here is where we take the derivatives we just found above. Like we found this from number 1. We found, what was it? I think this was from number 4, the one we, or sorry, this was, sorry. Need to slow down here. Okay, let's try it again. This was from number 2 that we just did, and this was from number 4 that we just did. All you're doing is you take the derivative function that you found and plug in the corresponding numbers here. So, pretty straightforward. Again, do not plug it into this, because this is not f prime. This is f prime, or f of x, not f prime of x, so keep that in mind, okay? Sweet, we're good to go. So now we come down to this part here, and now we are gonna maybe have a more specific definition for, say, when you're given a point, or given an x value, x equals 5, x equals -2, whatever it might be. So take a look at the derivative formula here, and it kind of looks familiar. If I bring back the other one, right, here's what the other one was, as x, not x, as h approaches 0. And we said it was like f of, what was it, x plus h minus f of x, all divided by, I believe it was h here. Yep. So maybe there's some similarities here. This is like the y value of the second term. This is the y value of the original term. And you might be like, Mr. Park, what happened down here? Let's use the slope formula one more time and kind of see what's going on here. Recall, if we're thinking about this as a general function, so we have this, we have a function that looks kind of like this. I'll just take a half of like the x squared function. And let's suppose that here's like, let's call this x comma f of x. And we've called this point over here x plus h, right? We're going to take the x value and add some h to it, maybe like 1 or 2, I don't know, right? That means the function is x plus h, f of x plus h, right? Use the slope formula, or yeah, use the slope formula here, and you'll notice something happens in the denominator, which is why we're left with h in the first place. I'll let you try that on your own, because I've already done this twice now, okay? But here it's nice because it's more specific. If you know what x equals, we can now use this particular formula more easily. So Let's go ahead and try it with, one's pretty easy. 2's got the square root in there, so I might as well do that one. So f prime of -2 is equal to, same idea, limit as x, not h, this is x now. As x approaches that value, we're going to take f of x, which is going to be just this guy, minus f of c. So plug in -2. I'm going to do this all by hand first, and I'll show you later what happens. And then x minus, in this case, whatever the x value was, which was -2. So we simplify things out a little bit just to clean it up. We are left with this, right? So instinct first should be, can I plug in x equals -2? Nope. Indeterminate form, not going to work. So maybe the same concept of what we just did in number 4 above here. You got some rationals up at the top that are being subtracted. What could you multiply the top and the bottom by? Go from there. Do not distribute this. You're going to resist all temptations to try to distribute this with this wacky stuff on the right-hand side, because eventually the x plus 2 will cancel out. Okay? Keep that in mind. Give that a shot. Pause this video if you need to. I'm going to move on to the final part, which is like combining all this stuff together. Okay? Okay, hopefully you understand how to do this and this. That's algebra 1. I'm going to skip past that. What I'm going to now do is go through the steps here. I'm not going to do the final one because the final one is just putting it all together. I'll walk you through the steps little by little, okay? So, labeling is going to be of utmost importance here, especially when we get to the last one where you combine steps 1, 2, and 3 together. You need to find a system that works for you. I'll show you how I do it separately, and you can kind of put the pieces together there. We're given the function f of x. We're given x equals -1. So the first question is, what is the coordinate point for f of x? Not f prime of x, f of x. If I plug it in, f of -1 here, plug it into the formula, you get -1 squared plus 4, which you should be able to do in your head, but roughly that gives us the coordinate -1, 5. I'm writing this in coordinate form. You can keep it in function notation. Doesn't really matter for this case, whatever helps you out. Okay. Now, step 2 is use a mathematical definition of the derivative at a specific point. We just did this about a minute ago. F prime of -1 is provided by the limit as x approaches that value, -1, of f of x, which is in this case the x squared plus 4. Let me just double check because I don't want to screw this up right now. Yeah. Minus f of c, or f of -1, which we already found out right here. It's 5. Divided by x minus the x value, which was found here. That's the x value that we just did. And so let's go ahead and do that. Oh, whoops. It's going to be minus -1. Simplify it out just to make things a little bit easier for us to read through. Try to plug in -1, first step, doesn't work because indeterminate form. And so now we try to see things out. How can I divide that bottom portion out? Instantly, you should notice that x squared plus 1, that is a very unique thing that we've seen in the past many, many, many times since algebra 1. And I hope you're saying a 6-letter F word. There we go. Cancel things out. Go from there. Now, recall, what does the derivative mean? It's going to give you some value, right? What does that actually mean? Think about the definition of the derivative. Slope of the tangent line. First word you said was slope. Wait, so you're telling me that f prime of -1, whatever the value is, 5, -14, whatever it's going to be, that's the same thing as like m in the slope-intercept form or the point-slope form? Who knew that algebra 1 and calc had so much in common? So finally, use point-slope form. You know that the slope is whatever the value was that you just found in step 2. You know your x and y value, or I should say your x1 comma the y1, and that's going to equal the, what is it called, -1 5, right? You now have point-slope form, y minus y1 equals m times x minus x1. Or if you're lazy like me, which you'll see in the key, I actually prefer using the original formula, because technically you know all the components except for the y-intercept, right? So solve for the y-intercept, and then go back, y equals derivative times x plus the y-intercept. Okay, that should pretty much wrap it up. Again, I'm just foreshadowing, or I'm just warning you, you're going to hate me tomorrow. I mean, most of you already hate me already, that's fine. You're entitled to your opinion, because it is your opinion. But you're really going to hate me tomorrow once you see how easy a lot of this becomes. don't take for granted what the definition is. Go back to the basics, the fundamentals, as I've repeated 20 million times in this single video, and then go from there.